students, good morning. Today the topic is the conductance of electrolytic solutions. At the outset, I would want to tell you that the important question in this topic is Kulrovich's law, because it has many applications in electrochemistry and is mostly asked in the examination. But to understand Kulrovich's law, we need to understand certain basic terms, which are what does this term conductance mean, and then we have related term. We have specific conductance. It is also called conductivity. Then we have equivalent and molar conductance. Last but not least, we have what is the effect of temperature and concentration on conductance. So let us go to the conductance first. What is conductance? Conductance is the ease with which current flows through an electrolyte or a conductor. What is conductance? It is the ease. Conductance is the ease with which current flows through a conductor or an electrolyte. So it is we know that it is the reciprocal. We denote it is denoted by C. C is equal to 1 over R. So it is a reciprocal of resistance. Then we need to know what are the units of conductance. We derive it from the units of resistance. We know the unit of resistance is unit of resistance. You know what are they? Ohm. Like this, and we write is this. इसको कुछ और बोलते हैं क्या? नहीं. So omega. Okay. So the unit of resistance is ohm, and here then the unit of conductance is therefore ohm inverse or omega inverse. The SI unit is Simon. SIE. Specific conductance or conductivity. This is another term which we have to understand before we proceed ahead. What is this specific conductance? It is also called conductivity. You know, it is the we derive this from the specific resistance. We have another term, specific resistance. So in order to understand specific conductance, we have to understand what is specific resistance. Specific resistance, it is the resistance of 1 centimeter long conductor. 1 centimeter long conductor whose area of cross section is 1 centimeter square. So this is the term specific resistance. Why do we need this term? Why do we need specific conductance and specific resistance? The reason for this is because if we want to compare the conductance or resistance of two conductors, if we take a conductor, two conductors of the same material of different lengths and of different areas of cross section, we will get different values, since we know that this conductance as well as resistance, they depend upon length as well as area of cross section. So in order to compare the conductance or resistance of conductors, we need to take the conductors of equal length and equal area of cross section. So in this case, what we take a unit of this of the conductor. The unit here we take that it is 1 cubic centimeter. Its length is 1 centimeter and its area of cross section is 1 centimeter square. And this the resistance of this 1 cubic centimeter of the conductor is called specific resistance, and the conductance of this is called specific conductance. Move towards what are the units of specific conductance and specific resistance. First, specific resistance. We know that resistance is directly proportional to length of the conductor and inversely proportional to area of cross section. This means that if we have a longer conductor, it will have more resistance than a shorter one. Similarly, if we have a thicker conductor, it will have lesser resistance than a thinner, पतला conductor. पतला से जो मोटा होगा उसका जो resistance है that will be less. तो इसको हम इस तरह भी लिखेंगे, रॉ, इसको हम ये चेंज करेंगे into equality. This is called rho L over A, or rho is equal to R into A over upon L. So what is this in this row? This is the constant of proportionality. This is the constant of proportionality. Constant of proportionality. And it is called specific resistance. इसी को कहते हैं specific resistance. तो यहाँ से हमें निकलेगा ये, अगर हमारे पास ये कंडक्टर है जिसका एरिया क्रॉस सेक्शन है 1 सेंटीमीटर स्क्वायर और इसका लेंथ है 1 सेंटीमीटर, जैसे मैंने पहले आपको बताया, देन रो इज इक्वल टू आर. इसका मतलब इट इज रेजिस्टेंस ऑफ द कंडक्टर हुज स्पेसिफिक रेजिस्टेंस इज द रेजिस्टेंस ऑफ द कंडक्टर हुज एरिया क्रॉस सेक्शन इज 1 सेंटीमीटर स्क्वायर एंड हुज लेंथ इज 1 सेंटीमीटर. इसके यूनिट्स जो है यहीं से निकलेंगे. हमें पता है कि आर का जो है दैट इज ओम, रेजिस्टेंस का क्या है ओम, बिकम्स ओम, ये यहाँ पर इससे माइनस हो जाएगा तो ओम सेंटीमीटर. सो ओम सेंटीमीटर इज द यूनिट ऑफ स्पेसिफिक रेजिस्टेंस. तो इसको हम कहते हैं स्पेसिफिक रेजिस्टेंस को कहते हैं स्पेसिफिक, इसको रेजिस्टिविटी भी कहते हैं, रेजिस्टिविटी भी इसको कहते हैं, रेजिस्टिविटी. तो इसका ऐसा यूनिट जो है वो है ओम मीटर. Now let us come to the term specific conductance or conductivity. We know that specific conductance is inverse of specific resistance rho, or it is equal to 1 over R into L over A, or it is equal to C into L over A. What is C? C is the conductance. So we know that conductance is equal to 1 over R, is inverse of resistance. So we can write instead of 1 over R, we write C and L over A. L over A is also, this term is also called cell constant. This is called cell constant. So specific conductance is equal to conductance. C is conductance into cell constant. Here we have specific conductance is equal to conductance into cell constant L over A. If we have an conductor of whose length L is equal to 1 centimeter, area is 1 centimeter square, then specific conductance is equal to conductance. Thus, specific conductance is the conductance of 1 cubic centimeter. It is the conductance of specific conductance is the conductance of a conductor whose length is 1 centimeter and whose area cross section is 1 centimeter square. In case of electrolytic solution, it is the conductance of an electrolyte enclosed in a cell whose electrodes are of unit area of cross section and are separated by 1 centimeter, or it is the conductance of, in case of electrolyte, this is the conductance 1 cubic centimeter. That means it is length, breadth and height. We have a cell whose length, breadth and height is 1 centimeter, और उसका जो conductance है that is called specific conductance. Specific conductance we know it is equal to L over A. ये हो गई conductance inverse of resistance, और ये हो गया cell constant. तो अगर इनके यूनिट्स हमें देखें तो इसका है 1 over ओम हो गया ये, इनटू ये हो गया सेंटीमीटर, ये हो गया सेंटीमीटर स्क्वायर. सो स्पेसिफिक कंडक्टेंस का यूनिट हो गया ओम इनवर्स सेंटीमीटर इनवर्स हो गया, क्योंकि ये सेंटीमीटर यहाँ सेंटीमीटर स्क्वायर है तो ये सेंटीमीटर हो गया. वी ऑल्सो राइट इट एज ओमेगा इनवर्स सेंटीमीटर इनवर्स. द SI यूनिट इज साइमन सेंटीमीटर इनवर्स. दिस इज अ यूनिट ऑफ specific conductance. Okay.